We're trying to solve a pretty wild looking integer equation here. Now, by the set integer, I just mean the natural numbers and their negative counterparts. So you would have minus 3, minus 2. It's a set of numbers, minus 1. And that's where we're looking for our solutions to this equation. Okay, it's a set of numbers. All right, now we're looking for an ordered triple that would actually satisfy this one equation and one unknown that you see right here. Now notice everything inside is positive. This first part, the radical, is certainly greater than 0. This binomial raised to the 4th power is certainly greater than 0. And definitely the absolute value is greater than 0. Okay. Now, a lot of information is given. 14 right here is already a really big deal because that means this radicand, the constant side is 14. So that means this radicand you see right here has to be less than or equal to 14 squared. And that's clear, of course, since the square root of 14 squared is equal to 14. Okay, and so since everything else is positive or non-negative, it can't be any larger than 14 squared. That is this radicand. Okay, now so it makes sense to go ahead and check what happens if you set it equal to 14, and it's pretty quick. It's fairly easy to see that if you set it equal to 14, that would imply that x must be 24. Okay, now if x is 24, that would make this part vanish, and we would need y to be negative 5. So we get x equals 24 and y is equal to negative 5. Y equals 2 minus 5, excuse me. Okay, and again, folks, just the arithmetic straightforward here. This would go to 0 if you made x equals to 24. We need it to be equal to 14 squared, which is 196, and so y would have to be negative 5. So we already have these two things fixed if it fits with the rest of the equation. Now notice that these other terms here have to all be equal to 0. That's what makes this an easier problem than you might first think. Okay, you're just guessing and checking based on some initial observations. So we know that x minus 3z would have to equal to 0. But we already know that x is 24, right? We already know that x is 24, so that implies that z has to equal to 8. And I'm talking about the variable z here, not the name of the set. See again, folks, we deduced that x was equal to 24 down here, okay? And so you have 24, and for this to be equal to 0, z would have to be equal to 8. So at this point, our candidate solution, without even checking the other part, the candidate solution would be x coordinate of 24, y coordinate of negative 5, and what do we get here? Z coordinate of 8. Now all we have to do is check to see. Remember, this is y, this is z right here, right? We have to check to see if that works here. We need this part to be 0 also. 8y plus 5z must equal 0. And that the conditions are certainly satisfied right here because this would give you negative 4, and this certainly, you would get negative 40 right here. So you would have minus 40 plus, again, y'all, I'm using y is equal to negative 5. So we'd have negative 40 plus 5z, or negative 40 is equal to minus 5z. We'll just write it that way. And again, that implies that z has to equal to 8. Okay, so it was more of a logic problem. If you tried to square both sides, it would get very messy in a hurry. But this is the solution, 24, -5, and 8. And by the way, folks, if you put this into Wolfram algebra, it will exceed the computation time. It can't figure this problem out. It tries to apply various things like squaring, I guess, or various other equation solving techniques. It can't figure it out. It'll crank and crank and crank. It'll say, if you don't pay for it, just you're doing the freebie part, it'll say the standard computation time is exceeded. But this is definitely a solution. I suspect it's the only solution, although I didn't prove it. But we are done. This is the solution. And hope you enjoyed.